The Moon has been our longest celestial neighbour and has been an incredible factor in the development of life on Earth. Creating tides along the oceans and lighting up the night sky, our Moon has been there for 4.5 billion years. But how did it get there? Welcome to the Daily Galactic. Today we're talking about the formation of our oldest friend in the night sky, the Moon. Astronomers all over the world have wondered about where the Moon came from and how it was formed for years. Throughout this time, 3 primary theories have been established to answer this question. The most accepted of these theories is known as the giant impact hypothesis. In short, it suggests that our Moon was formed in the early evolution of the solar system, when a massive object smashed into the young Earth. Just like the other planets, the Earth was created when the leftover cloud of gas and dust that formed our Sun combined slowly under the force of gravity to create all of our planets that we know and love. The early solar system was a truly violent and chaotic place, full of crashing clusters of rock, metal and gas. During this time of rapid formation and disarray, it was extremely likely that there were other celestial bodies and planets that do not exist today. One of these objects could have easily crashed into a young Earth. The planetary body that has been theorized to have crashed into the Earth actually has a name. It's called Theia. It was an object with a similar size to Mars, and when the epic collision happened, vaporized fragments of the young Earth's crust were thrown out into the harsh environment of space. The powerful force of gravity bound these ejected particles together, and in the same way the planets were formed, the Moon was created. A moon that is the largest in the solar system in relation to its host planet. This sort of formation explains why the Moon is made predominantly of lighter elements. It's less dense than the Earth because the material that it was made from came from the crust of the Earth, while leaving behind the dense rocky core of the Earth alone. What was left of Theia's core centered along the Earth's ecliptic plane, the path that the Sun travels through the sky, and where the Moon orbits today. According to NASA, the collision that occurred was 100 million times more powerful than the collision that wiped out the dinosaurs. Although it's believed to be the most likely way that the Moon was formed, the theory faces some challenges. The majority of models suggest that more than 60% of the Moon should be made up of material from Theia. However, this is not the case. When moon rocks brought back from the Apollo missions were studied, the composition between the Earth and the Moon were found to be nearly identical. They both only differ by at most a few parts in a million. This contradiction has cast a long shadow in the giant impact model. A later hypothesis, thought up in 2017, came up with a solution to this problem. It's called the multi-impact scenario, where a rain of small debris fell onto the Earth instead of one giant object. The rest of the theory is the same, where vaporized material blasted into space eventually clumped together to form the Moon. Another secondary leading theory is called the co-formation theory. Moons have been known to form alongside their parent planet, and so using this theory, gravity would have caused the two bodies to draw together at the same time. Such a moon would have an incredibly similar composition to Earth, and it also explains the positioning of the Moon. However, although the Earth and the Moon are made of basically the same material, the Moon is much less dense than the Earth. This would not be the case if both objects started with the same heavy elements found at their core. But what if the Earth's gravity pulled in a passing object? This idea presents us with the capture theory. Many moons, such as Phobos and Deimos from Mars, were captured by the gravity of their parent planet. In Earth's case, it could have been that a rocky body formed somewhere else in the solar system and drifted its way into Earth's orbit. This supposition explains how the Moon and the Earth's compositions differ slightly, but captured objects are usually strangely shaped and not spherical, and their paths don't line up with the ecliptic plane of their parent planet. the Moon is both spherical and lines up extremely well with the Earth's ecliptic. Although the last two theories explain some factors of the Moon's existence, they leave us with more questions than answers. Currently, the most likely theory is a giant impact hypothesis. Which one do you think is most likely to be the case? Let me know in the comments below, and be sure to subscribe to catch my next video on Sunday. You can also turn on post notifications so you never miss a video. See you soon.